Hello class. Today we're going to be looking at completing the square. It's yet another method that we can use to solve a quadratic equation. This one is particularly helpful when we're looking at certain characteristics of our quadratics, which we'll get into in just a few days. So let's take a look at completing the square. The process that we use for completing the square is to look at the very first two terms, the squared term and the x term. So if we have x squared plus bx, and that's a binomial, two terms, then we're going to add another term, and that term that we are going to add is going to be, b over 2, where b is this coefficient, and then we're going to take that whole term and square it. So that b over 2 squared is the square of half the coefficient of the x term. And then when we put that all together, it makes a perfect square trinomial. So we would be doing, we have that x squared plus bx. If we add b divided by 2 and square it, that's a perfect square trinomial that can be factored into x plus b over 2 squared. Let's see what that looks like with numbers. Here's our first example. It says, what term should be added to each binomial so that it becomes a perfect square trinomial? And then we're going to factor this. Now, notice that our leading coefficient is 1, and that's going to be very helpful when we're completing the squares. So our b term, though, is 6. So to get b over 2 squared, we're going to take 6 divided by 2, and then we're going to square that. Now 6 divided by 2 is 3, so it's going to be 3 squared. 3 squared is 9, so we're going to add a 9 to that binomial. Now we have a perfect square trinomial, which can be factored into x plus, and then it's going to be the b over 2, which is just that term before we squared it. So it's going to be x plus 3, and then we put a squared on that. So these are the two things that they're asking for. Let's try another one. Once again, the same directions. What term should be added to each binomial so that it becomes a perfect square trinomial? This time, though, what's different is that this is negative, and that does belong to the b, and it's an odd number. So when I take negative 5 and I divide it by 2, and I'm going to square that, I'm going to leave it as a fraction because negative 5 divided by 2 does not give me an integer. So I'm going to leave it as a fraction rather than a decimal. So I'm not going to do anything to it. Let's go ahead and square it. When we take a negative times a negative, it's going to be a positive. And 5 times 5 is 25, and 2 times 2 is 4. So we're going to add 25 fourths. That's our b over 2 divided by, or then squared. So that is the b over 2 squared. So then when we factor that, it's going to be x, and it's going to be squared as a binomial. That's squared. And it's going to be that b over 2. Well, that b over 2 is right here, and it's a negative. So it's going to be x minus 5 halves squared. And let's just do one more. And we've got, okay. This time it's positive, but look at that. Oh my goodness. B is 2/3. So we're going to have 2/3 divided by 2, and then we're going to square that. Well, 2/3 divided by 2 is 2/3 times 1/2. So that gives me 1/3. And keep in mind we're still squaring that. So 2/3 divided by 2 and then squared is going to be 1/9. So that's what I will add to this one. And then to factor that, it's going to be x plus 1/3 squared. So let's take a look at how we use the completing the square to actually solve a quadratic and get some solutions for it. So I've got listed here a beautiful quadratic. It is a trinomial, x squared plus 4x minus 1 equals 0. I want just that binomial on one side. So it's going to be x squared plus 4x plus something equals, but to get that, I'm going to add 1 to each side of this equation. So I'm going to have 1 on this side. And because I'm going to add something to an equation, I want to add it to both sides so that it remains equivalent. So let's find out what we're going to be adding here. We have b is our 4, and we're going to divide by 2 and square that. Well, 4 divided by 2 is 2, and so we're going to square 2, which gives us 4. So that's what we're going to add. We're going to add it here, and we're going to add it here. So now we're going to factor this perfect square trinomial. It is x plus, and b over 2, remember, is 2. So it's x plus 2 squared equals, and let's combine these like terms. 1 plus 4 is 5. Now we're going to go back and apply that square root property. So we're going to take the square root of this side and the square root of this side. But remember, we need to have that plus or minus there. So we get x plus 2 is equal to positive or negative square root of 5. Well, we want to know the solution for x, so let's subtract 2 from each side. And we're going to have x is equal to negative 2 plus or minus the square root of 5. Let's try one more example, and this one is going to be just a little bit different because, so in this final example, we've got a trinomial, but it's a little different than anything we've seen so far because it has a leading coefficient with a 2. We don't complete square with leading coefficients of 2 or any other number other than 1. So we're going to divide the entire equation by 2. So that's going to give us x squared plus 3/2 x minus, and negative 4 divided by 2 is 2. And that's still going to equal 0 because 0 divided by 2 is 0. So now we're going to add the 2 here to put a binomial that we can complete. So we'll have x squared plus 3/2 x plus something to complete that trinomial is equal to 2 plus that same something. So b is 3/2. We're going to divide that by 2, which is the same thing as taking 3/2 and multiplying it by 1/4, or I'm sorry, 1/2. Getting ahead of myself here. There we go, 1/2. And remember, we're not just dividing by 2, we're also going to square it. Got that part. So 3 times 1 is 3, 2 times 2 is 4, and we're going to square that. And 3 squared is 9. And it's going to be over 16. Now we're going to do that to both sides. All right, so this is going to get factored into x plus 3/4 squared. Remember, this 3/4 is the b over 2. That's what we found it right there. And then we're going to take 2, which is going to be 32/16, and add it to 9, and that gives us, it's going to be over 16. 32 plus 9 is 41. So we have 41/16. Then we're going to take the square root of each side. Make sure we do a plus and minus here. I'm going to just change colors a little bit so we can see more distinctly. We're going to, oops, not yet. We're going to have x plus 3/4. is equal to plus or minus the square root of 41, and the square root of 16 is 4, so we're going to put that there. Now we'll subtract this 3/4. So now I'm going to change colors. Let's go to, we'll have x is equal to, and notice that 4 and 4 have a common denominator, so we're going to just put that underneath here. And we're going to have -3 plus or minus the square root of 41 as our numerator. That one's a little more complicated. We fortunately will not have to work with those as often.